Let's consider range of functions. Okay, so the first thing to consider when you're looking at the range of any function is what kind of function do you have. So let's just jot down a few different types of function. And one more type of function. Okay, so let's have a look at each of these in turn. If we're considering the range of each of these, we'll assume for the moment that they're defined for any real number. Okay, so for the moment we'll just assume these have any real number and we'll consider the range in that case. So this one here, we've got sine x, that's the primary function that we have here. And then there's some other stuff, times 4, minus 2, we'll worry about that later. The main thing is we need to think about what we know about the sine graph, and we know that that's limited. It has a maximum value of 1 and a minimum value of minus 1. Therefore, this function, or this bit of the function, we know varies between 1 and minus 1. Therefore, we know that 4 times sine x must vary between 4 and minus 4. Subtracting 2 from each of those values tells us that f of x, our range, is between minus 6 and 2. Plus minus 4, subtract 2. And because sine of x can actually equal 1, we have less than greater than or equal to and less than or equal to. Okay, now let's consider this function. Again, the primary function is e to the x. It's been transformed slightly, but that won't matter really. So e to the x, we know it has this kind of shape. So it will asymptote out at y equals 0 and go up to infinity. Translating it by 2 won't affect the range of the basic function. So we know that it goes from 0 up to infinity. Timesing those by 3 will not affect anything. Even this function is still between 0 and infinity. Then I plus 1. So I now know that g of x must be greater than 1, and that's it. We don't have to write less than or equal to infinity. Infinity is not a number, it's a concept. So as long as I know that this function, g of x, is greater than 1, we infer from that that there's no upper limit. Notice that I've said strictly greater than 1. As this has an asymptote, e to the x equals 0, I will never actually reach 0 there. Therefore, I will never reach 1 when I add 1 to it. Okay, next, we've got a quadratic. We should remember from AS, the best way to find the minimum value of a quadratic, I know it's a minimum value because it's a positive quadratic, is by completing the square. So remember, minus that number squared. So that gives me plus 5. So I know that this will have its turning point at x is 2, y is 5. By the time you're doing A2, you probably won't need to sketch it. However, it's worth doing just so that you can then say h of x is greater than or equal to 5. Again, in this case, it can equal 5 because by plugging in x is 2, I can actually get the value 5. Finally, we've got a modulus function here. So we know that modulus function is always positive, meaning the lowest this can be is 0. Kind of similar to our completed the square form, where we knew anything squared, the lowest it could be is 0. So if the lowest that this can ever be is 0, timesing it by 3 will not affect that. I then subtract 3. So we kind of know that our graph will look something like this. And therefore we have that I of x is greater than or equal to minus 3. Again, no upper limit. Because I can plug in any x value, I can go arbitrarily high if I want to. Okay, so when considering the range of a function, the main thing you need to look at is what type of function do you have. Consider its range, and then just apply any transformations that are required. Okay, we'll just consider how that would change if we also had a limit on our domain. Okay, so we considered those for any real number, but range and domain are intimately linked. You cannot really know the range of a function without knowing its domain. So in this case, we'll take the domain as 0 to 2 pi. We know that 0 to 2 pi would be a full oscillation of this function, and therefore, if I've got a full oscillation of sine, I can have all of its values. The range in that case would be unaffected. Okay. It's possible that I might only have half an oscillation. In a quick sketch, tells me that in that case I cannot get the negative values. Sine is limited to between 0 and 1. Therefore, my range in that case would be limited to minus 2 when sine x is 0, and a maximum value of 2 when sine has the value 1. Okay, now let's create a domain for this one. We're going to go for 0 up to, let's say, 10. All I'd have to do in this case is, because I know that e to the x looks something like that, smallest values for small x's, largest values for large x's, I can know that my minimum value of gx will occur when I plug in my smallest value of x. Now, although I'm not actually allowed to use 0, I'm going to plug 0 into here to get 3e to the minus 2 plus 1. And then I'm just going to fix it. Although I'm technically not allowed that number, I can say that g of x is strictly greater than that. Okay, I've plugged 0 in, even though technically I'm not allowed to, but it tells me what that number is I can approach. I can get infinitely close to that value. Similarly, I can then plug in 10. Again, it would be a strict inequality because I'm not actually allowed to plug in 10. And that would just give me 3e to the 8 plus 1. We'll keep those values exact. There's no need to put them in the calculator and find out what they are as a decimal. That's nice and exact. Okay, for this one here, we're going to say that x is greater than, let's say, minus 3 and less than 3. Okay, so again, we completed the square of this, and we knew that in completing the square form it looked like that. But now I've got this restricted domain. So again, we know the minimum value of this graph occurs at x is 2, and it gives me a value of hx is 5. I'm allowed to plug in that minimum value, x is 2, so that will still definitely be the lowest value I can reach, 5. Quickly, I should consider which of these at the extremities of the range would give me the greatest value of x. Again, if you're not sure, quick little sketch, turning point at 2, 5. If I'm only allowed to plug in up to 3, I can only go just a little bit beyond where the turning point is. Clearly, minus 3 is further from the turning point, it will give me a higher value. So plugging in minus 3 into here gives me minus 5 squared, 25, plus 5 is 30. So I know that h of x is greater than or equal to 5, but strictly less than 30. Again, because I'm not technically allowed to plug in minus 3, However, I can get as close to plugging in -3 as I want. Okay. Finally, with this one, again, let's just create an invented domain. So we'll go for -2. Again, quick sketch. I know that it has a turning point where the modulus takes effect at -4. And then it's quite steep after that. So in this case, I'm not actually allowed to use my turning point. The modulus will not in this case ever take an effect. So I would just say that x is between plugging in -2, I would get 2 times 3 is 6, -3 is 3. So I can't actually have that value. Plugging in 5, I would get 9 times 3, 27, 24. Okay, so check whether the key feature is important. It wasn't in this case. I just substituted in and find the values. If, which is what I think I meant to write down, I had -5 and 2, then the modulus would take effect. And we would see that I can get the minimum value at the turning point, as I already knew. And the maximum value will be at the point furthest from the turning point, in this case, just 2. So if I plug in 2, 6 times 3 is 18, -3 is 15. And because I am allowed to plug in 2, I am allowed to have 15. And again, I can reach that turning point now because I am allowed to plug in -4. Okay, so 2 main things to consider when looking at range of a function. Number 1, and most fundamentally, what kind of function are you working with? If it's trigonometry, such as sine or cos, you know it's limited to between 1 and -1. If it's e to the x, you know that it's got an asymptote at y equals 0 and then goes up to infinity. Quadratics complete the square, and you can adapt this method for any other kind of function you meet. Secondly, do you have a full range of functions, a full range of values available to you? Have you only got half an oscillation for sine or cos? Are you only allowed to plug in some limited set of values of x, in which case you must consider the extremities as well as the type of function you have. Considering all of those things should allow you to answer any question on range or domain.